Yeah, now we'll be starting with the topic, the solubility. Solubility of solute in a given solvent. As you all know that we have already discussed in the previous topic that solution consists of two components, that is, one is the solute and the other is the solvent. And we know that for example, I'm taking a glass of water and I'm adding sugar to it. So sugar is present in a small amount and it gets dissolved, so that means sugar is considered as solute. And the water which is taken in a large quantity and which dissolves the solute is regarded as a solvent. So we are now considering the solubility of solute in a solvent. So what do you mean by the solubility? First of all, you should know that what actually the solubility is. So solubility is, that means I'm just explaining with an example. Just look at the board. It's like that. You have you can say a flask which is filled with water, right, and I am adding salt, or you can say sugar to it, right. So I'll be adding salt and I'm just stirring it with the help of stirrer, and just stirring it so that it gets dissolved. So that means now how much salt get dissolved in water indicates the solubility of you can say a solution, or a solubility of solute in a solvent, or you can say the ability of solvent to dissolve solute in it. So similarly, like in this case I added salt, in the second case I am adding sugar, right, or I can take another solute. For example, I am adding sand. So in three of the cases, when I am considering the salt, I am considering the sugar, I am considering the sand. So they are getting dissolved in water, but the ability of water to dissolve these components is different. It is different for salt, it is different for sugar, and it is different for sand. And as we did that, there are three kinds of solutions: true solution, colloidal, and suspension. So depending upon it, it is going to form a different kind of solution depending upon the size of the solute particle. So coming to the topic, that is the solubility, that means this water has the ability to dissolve salt, sugar, and sand. The ability to dissolve all these three is different for a different solute. So that means different solute gets dissolved in a given solvent in different amount, right? So that means the solubility. So the solubility means you can say the ability of solute to get dissolved in solvent, or we can say that it is the ability of solvent to dissolve solute in it, right. So in order to get a uniform result, we have considered the amount of solute. We have just fixed the amount of solute as you can say in grams, and the mass of solvent as 100 grams. In order to get the uniform result, we have just fixed those values. So I can just you can say manipulate the definition of solubility in a better way. That is, it is the amount of solute in grams present in 100 grams of solvent. So the solubility means it refers to the amount of solute in grams, particularly the unit which is used is grams, present in 100 grams of solvent. So this will indicate the solubility of any substance, any solute in a given solvent. And the mathematical relation which we are going to use for it is that means how we can get the solubility mathematically, that it's indicated by the weight of solute divided by the weight of solvent into 100. By doing so, we get the percentage, solubility percentage, that how much weight of solute is actually getting dissolved in the 100 grams of the solvent. And if in case you don't have the weight of the solvent, we can just convert this relation into the weight of solute divided by weight of solution minus weight of solute because weight of solution minus weight of solute is obviously going to give the weight of the solvent, and that is what we needed, right, into 100. So by using this relation also, we can find the solubility of a solute in a solvent, right. So this is how, this is what we mean by saying the solubility. So just keep in mind, the concentration and the solubility both are two different things. Yesterday, in the previous topic, we did the concentration, and now I am doing the solubility. Concentration means the amount of solute which is present in a given mass of solvent. That means, or you can say, I'll just repeat again, just listen to me carefully. We have the two definitions, that is the solubility and the concentration are two different things. When I am saying the concentration, it means the amount of solute present in the solution. We are not considering that whether it is dissolved or it is just left, or you can say it is just occupying the bottom, right. We are just concerned that how much solute we are adding to the solution. So if when I am telling you that yes, this much solute I have added to the solution, that means the concentration, that is not the solubility. But when I am talking about the solubility, it means that the amount of solute which actually dissolves in the given amount of the solvent. So in this case, we consider the solubility factor. That means it should be dissolved. It does not matter that yes, it is present. Suppose you are adding 5 grams of sugar to a water in 100 grams of water, or any you can say a known volume we are taking for the water. So if you are adding 5 grams of sugar into the water, so if I am talking about the concentration, so that means the concentration is 5 grams. You have just added the 5 gram of sugar into the water, right. But when I am talking about the solubility, we mean that how much amount out of 5 grams is getting dissolved in the given you can say the solvent. So suppose if I say that out of 5 gram, 3 grams gets dissolved. So 3 gram is going to indicate the solubility and 5 gram is going to indicate the concentration. So the concentration and solubility both are two different factors, right. So this is the solubility, that the amount of solute that gets actually dissolved. You have to mention this word dissolved, because when we are talking about the solubility, at that solute should get dissolved in it, right. So for the uniform result, we have just fixed the mass of the solvent as 100 grams. So we can say the amount of solute in grams present in 100 grams of the solvent. So this is how we calculate the solubility. Now on the basis of solubility, that which solvent dissolved the solute up to which extent, we have just divided this solution into different categories, right. So on what factor I have said? It is on the factor that how you can say what is the solubility, or which solvent can dissolve solute up to what extent. We have just classified the solution into two categories, right. So the two categories we have is saturated solution and unsaturated solution. Now what is the difference between the two? Unsaturated solution is that which can, suppose I have taken I'm just explaining with an example for better understanding. See, I have taken you can say a flask which is containing a solvent. The solvent can be anything. It is not compulsory that you take water as a solvent always. There are many more solvents also, though the water is a universal solvent, but still we have many more solvents like benzene, carbon disulfide, so many more solvents can be taken. Right. So I've just taken a solvent and I'm just dissolving a solute into it. Right. So what is going to happen? I'm just dissolving the solute, I'm stirring it, solvent is going to dissolve that solute. Right. So this is occurring at a fixed temperature. That means I'm not altering the condition of temperature, the temperature is fixed. So I'm adding a solute and the solvent, I'm just stirring it and the solvent is just dissolving the solute. And what happens, I add more and more solute, I just stir it, solvent is again dissolving it. But the point will reach when the solvent will you can say will dissolve the solute up to more concentration, or it will not dissolve the more solute, you can say. Again, I am just framing an example for you. See, I have taken a glass of water, and I'm adding a sugar to it, right? I'm adding a sugar, I'm just stirring it. I've taken a glass of water, okay? I'm adding a sugar, suppose I have added 1 spoon of sugar, and just stirring it. What happens? That sugar gets dissolved, right? And the temperature is kept fixed. Just keep in mind the temperature is fixed. I'm not heating the solution, or I'm not cooling the solution. The temperature is fixed. This activity is occurring at a fixed temperature. I'm adding the sugar, I'm just stirring it, and the water is dissolving that given sugar, right? I just add 1 more spoon of sugar to it, I'm just stirring it, again dissolve that sugar. Then I add 1 more spoon, I'm just stirring it, again it dissolves. So sometimes in certain cases what happens, when you add more sugar to it, it will stop dissolving. And we have a kind of solution that which can dissolve, like I'm adding more and more spoons, and it is just that solvent is making that solute dissolved in it. So on the basis of that, we have 2 kinds of solution, unsaturated and saturated. So unsaturated solution is that in which I'm adding a solute and I'm just stirring it, and the solvent is just getting it and just making it dissolve in it, right? I'm adding more and more solute, then again it is just dissolving it. So that means unsaturated solution is that which can dissolve as much as solute as at a given fixed temperature. That means as much as solute I add to it, it goes on dissolving and dissolving, right? So that means there is no point as such reached in which the solute is not getting dissolved. So those solutions which keep on dissolving the solute at a given temperature, they comes under the category of unsaturated solution. Right, and when we are talking about the saturated solution, suppose I say I've taken a glass of water, I'm adding a sugar to it, I'm just stirring it, what is going to happen? It is also occurring at a fixed temperature. It is just dissolving it. I'm adding more sugar to it, it is dissolving, okay? But when I add, you can say a bowl of sugar to it, and I'm just stirring it, so what happens? The few crystals of sugar get dissolved, and the few crystals after stirring also, they are just, we can look at the bottom that they are settled at the bottom. So that means that saturated solution is not dissolving that you can say the solute, more solute at the given temperature. So those solution which cannot dissolve as much as solute we add to it at a given temperature, they come under the category of saturated, right? So just repeating again, unsaturated can dissolve as much as solute at a given temperature, and saturated can dissolve only a fixed amount of solute at a given temperature. After that, the solute particles you can say keep on separating, and we can see them settle at the bottom, right? So the solution which can dissolve as much as solute we add is unsaturated, and the solution which can dissolve solute only up to certain extent at given temperature is said to be saturated. And now you are familiar with the saturated and unsaturated. We have one more condition which comes under the saturated, is the supersaturated. Supersaturated. Now what do you have any idea when I'm talking about the supersaturated, what does it actually means? Okay, tell me, what do you mean by a man? Obviously a male, right? And when I say a superman, then what does it mean? It means that man has a quality of man, definitely, but the quality, and it has many qualities more than qualities which are possessed by the man, means you can say the extra powers he has, okay? So similarly, it is a saturated solution, but it is a supersaturated solution, means it has a power of saturation, but still it has the extra powers, so that is why it is called as supersaturated solution, right? So supersaturated solution is that in which it is actually a saturated solution which can dissolve solute more than its saturation level. That means that we are taking a solvent, we are adding a solute to it, and it is dissolving that you can say the solute in it, and it is getting saturated. Saturated means a point is achieved where it is not going to dissolve more solute in it, right? But when I say supersaturated, that means it is dissolving the solute more than its ability to dissolve that solute in it, right? So that is called as the supersaturated solution. Now, how can you can say this supersaturated solutions are made? So they are just like, for example, I'm dissolving a nitre, I'm making a nitre solution, I'm dissolving the nitre in the given solvent at a fixed temperature. What happened? That it goes on dissolving, but up to a certain level, its dissolving power, or you can say the power of the nitre to get dissolved in the solvent cease, and it just starts separating out, right? So that means the point is reached where it has become the saturation. That means the saturation level is achieved. Now, if I wish to make that solution, the saturated solution, supersaturated, so how can I make it? I can just make it by increasing the temperature, because when I'm increasing the temperature, I'm just heating it, I'm boiling it. So what is going to happen? The ability of solvent to dissolve the solute will increase. And how much it is going to increase? It is going to increase more than its saturation level. So that means it will possess the more amount of solute present in it as compared to the, you can say, the ability of saturated solution to, you can say, to dissolve the solute in it, right? So it becomes a supersaturated solution. So anytime we can convert the unsaturated into saturated by heating it, and similarly we can make the saturated converted into supersaturated by just heating it, because when we heat it, the ability of solvent to dissolve the solute just increase, and it becomes you can say the solubility of solute in a solvent just increase. So this is how we can convert the unsaturated into saturated and saturated into the supersaturated. So these solutions can be interconverted by just increasing the temperature, right? So this is how we classify the solutions depending upon their ability to dissolve the solute in them, right? So these are the three kinds, and we are taking one more topic into consideration. We did in a previous lecture that we do have a mixtures in which, or you can say a solution in which gases are dissolved in liquid, right? I think you remember. So yeah, I'm talking about the carbonated drinks that we all relish to drink, right? So I'm talking about the carbonated drinks. So what is there in carbonated drinks? We have CO2 dissolved in water, plus some flavoring agents are there. I told you in a previous lecture, that is why we get to have Coke, Sprite in a different flavors we get. So there is a flavoring agent as well, right? So what happens in the carbonated drinks? So that means solute is gas and the solvent is liquid, and they both unite to form a mixture. Mixture comes under the category of solution, so obviously it is a solution, and out of it, it is a homogeneous. That means we don't get to see different boundaries between the solute and the solvent, right? This you already know. Now, what happens when we are talking about the carbonated drinks? So what happens that you must have seen that you can say the bottle of this thing, Coke or Sprite and all, they are just bounded by the knob, and whenever you just open that knob, you get a fizz sound, and sometimes you can say sometimes the cold drink also moves along with that, right? So you just have to open it carefully. You do that, and you know what is actually in it. What is you can say the chemistry involved in that? Obviously, it is a solution, a homogeneous solution. But what has actually happened if we say about the physical conditions which are required? So we have just increased the pressure. The gases get dissolved in a liquid by just increasing the pressure. More you increase the pressure, more is the solubility of gas in liquid. That is why they are bounded by the knob, right? They are bounded by the cap, you see in case of carbonated drinks. And what happens when you just open that cap? What happens? The carbon dioxide, the solubility of the gas in the liquid decrease, because when you are opening the cap, the pressure decrease, and when you decrease the pressure, the solubility of gas in liquid, or you can say the solubility of CO2 in water, gets decreased. And what happens? CO2 just escape through that water in the form of fizz. That is why you get, whenever you open, you just get to see a gas coming out from the cold drink, right? So that means by increasing the pressure, if we are increasing the pressure, the solubility of gas in liquid is increasing. It is also stated in a higher classes by an Henry law, which states the mass of gas which dissolved at given temperature in the you can say in a given solvent in a given liquid depends upon the pressure. More is the pressure, more mass of gas gets actually dissolved in the liquid. And when you just decrease it, then what happens? The solubility of the gas in liquid just decrease. So that means the gas starts separating out, the solute starts separating out from the solvent. So by increasing the pressure, we can increase the solubility of gas in liquid. And similarly, if I am increasing the temperature, what happens? If I am asking you to consider that I am increasing the temperature, what is going to happen? The gas will remain dissolved in liquid, or it will just separate out. So what comes into your mind? Yeah, you're right that when we are increasing the temperature, so obviously the gas molecules are gaining the energy and they start moving faster. So that means they just escape, and the solubility of gas in liquid decrease. So that means by increasing pressure, the solubility of gas in liquid increase, but by increasing temperature, the solubility of gas in liquid decrease. So this is how the temperature and pressure factors affect the solubility of substance of solute in a solvent. So this is how we carry out the solubility. And moreover, now we will be studying about the solubility curves as well. So when we are talking about the solubility curves, so what we see, so first of all you should know what is actually a solubility, or sorry, what is actually a solubility curve. Solubility we have already done, so you already know about the solubility, right? So I am talking about the solubility curve. Solubility curve means, and we know that the solubility is greatly affected by the temperature. As we have seen that when we were increasing the temperature, the solubility of gas in liquid was decreasing. So this is how now we are just going to start with the solubility curves.